Okay, so I'm already recording. Yeah, that's good. So I'm going to cover three topics today. Function template, and also I will talk about function pointer and also lambda expression and class templates. The chapter I mentioned here, those are for the reference book. The book, they are being covered at chapter 8, chapter 9, and chapter 16 if you want to get more information about these three concepts. All right, so I'm going to show you the example I started last week. How do I get out of this? Yeah, this is under CPP 15. The program I would like to show you first is the simplest one, is just the FN template. Okay, this is the program that we look at the tail of the last lecture. So let's use this as an example. If you remember the PowerPoint slides I have, I have two different functions. They're sharing a lot of logical or conditional structure about what you want to do. It's essentially trying to say, you know, which one is minimal in this example. But in the example I'm going to show you here is saying that whether the input value is actually follow the range. Let's take a look at this very, very carefully, just one by one. So I separate this into a few lines. The first one is the template introducer. And the second line starting from here is essentially the function. So if you look at the function, if I can write this function without the template, this is the way I will write it. Okay, let me just say, this is the way I'm going to write it. Bool is range. And I'm going to say, assuming this is integer, and I'm going to return the upper is going to be maybe 40, and then the lower is going to be 10. Assuming I have a function without template, looks like this. So you can see that this function was defined such that it will return a Boolean value regarding whether the input argument value is within the range of lower and the upper. So that's the function we try to do. So you will see, compare this 4 line or 5 lines of code and those 3 lines of code above, 3 or 4 lines of code above. The only difference is essentially something to do with this introducer. So introducer, by the way, if you see in your code, any code, you see a pair of smaller than sign and then greater than sign. If you see a code, any code looks like this, it's a template. It's a template of something. It could be either a template of function or the template of a class. Essentially, in my opinion, it's not really a template of a function or versus template of a class. It's really of a template for a piece of code. It turned out that piece of code is a function, then it's a template for function. If that piece of code turned out to be a class definition, then it's a template of a class. So essentially what we're teaching you is that this is a general way of defining a template over a piece of code. All right, so let's take a look at that. So therefore, I'm saying that this piece is the code part. And this piece is the template parameter. Essentially, what a template is really based on the parameter you replace in the code, and such that make your code become whatever you want to have, is integer or whatever data type what you have. So in this case, you can see that. But by the way, this 5 lines of code here is equivalent to the below if we actually do this way. Let me just tell you that what is this equivalent is going to be is in range, and then I have 3 parameter in the template. So it's going to be integer because it's an integer, and then it's going to be 40 and 10. Okay, so if I want to use the template to generate the code below, then this is the way I'm going to call it. Of course, this template has a function that you're going to put some parameter inside there. Okay, so let's take a look at this. Is first, how do you specify the parameter part, and how would that relate it to the code part, such that you can do this kind of how do I say that? This kind of replacement in terms of a label. It's essentially switch the label. So let's take a look at this part. The template, I have a 3 parameter. One parameter is a type name T. That means anytime I got a T, I know that's the type I'm going to replace in the template over here, the first parameter. And the second parameter is a variable, is integer upper, and the third parameter is integer lower. All right, so in this case, what you will have is that you can see here I have a T, and therefore this T is going to replace whatever value you put in the first argument. So in this example, if it's int, then whenever you have a T, it's going to be int. So therefore, if you look at this function, it's going to be int, because this is a replacement of T. Okay, the second one and the third one is the upper and lower. They're representing upper and lower here. So in other words, whatever value you have here, I will interpret that value as an integer, and then I will shovel in your code, and such that this upper will be replaced with the value 40, which this will be replaced at the value 10. So by defining this line, let me actually get rid of my comment so you can see the whole thing easier. So this is the way you can specify a template. So essentially is this, in this case, is a function, but really what we have is just a piece of code, and then you just replace whatever parameter you have within that pair of smaller than and greater than sign. It will just symbolically replace, and then it will generate a code that's equivalent of this, like this, at runtime. Okay, so going to generate this. No, not actually. I might have made a mistake. If I say this is the code that's supposed to be generated based on the template. Is this piece of code, if I want to use it, let me actually use this example. You can see I have a piece of code like this, right? I have a code like this. You see that I'm saying is in range, double 410, and then the argument is 55.0. And as I said, is going to be using the template and generate a code looks like this. And my question to you is that, do you think this is happening at the compiler time or at the runtime? Aaron? Okay, so if I do this, okay, if I may, if I, instead of doing double, I said I do this, class thing, or maybe I just say thing. Okay, I just say thing, right? It's a class. And within this code is not even being defined, right? Let's try to compile this code. Well, the answer, I just want to tell you, this is all happening at compiler time, nothing to do with runtime. But I want to show you this. Hopefully this will be clear things up. I have a thing, but you look at the code, I don't even have a class thing defined or included, right? It's just like this. So I'm going to compile the code. Let's see what kind of message I will generate. Sorry, is TMP. Okay, so you can see that here, it basically say the compiler saying that I'm using an undeclared identifier. So the compiler is looking at this and saying that, wait a minute, you're trying to generate the code, but the code doesn't have the class being defined. So this is a compiler time error. The compiler time at that time, they try to check all the syntax and semantics related to whatever parameter you need to put in at the compiler time. So at this time, it's already checked. Okay. So let's go back to the previous one. So assuming I do this, if I do, I define a class thing, and this is just a dummy class. I'm going to put just a dummy class. And then I will say private, protected, and public. And then I have nothing. I probably just put an integer sequence number. Okay, I just put some kind of dummy. Now I can try to compile. Okay, so now I have a different arrow. The reason it has this is that now I try to replace, again, this is still compiler time. It's not runtime. I try to put thing as a first argument. But if we look at the code, hold on. If I look at the code within here, it says that the argument value is what? Is supposed to be type T. And what's type T is a thing. And thing doesn't have, thing is not an integer or that or whatever. And therefore, this argument, this operator smaller or equal than 40, a number, is essentially does not have a conversion. Okay, so therefore, this one, you will have a arrow looks like this. Okay. All right, let's try to do a better one. So let's replace this thing with, say, double. Okay, now it should work because double is the type that's actually convertible to that integer. And I have that parameter 40 and 10 as an upper and lower. Now I have no problem, so I can run the program. And then it says it's false. Yes, error. Yes, you can do that. Yeah, you definitely can do that. So that's actually related to, there are two ways you can look at this in this particular example. I can potentially put the operator overloading here. To put the operator overloading in the thing to actually convert that. Or I can define the whole thing as a class template and put the operator overloading in the template as well. There's two different ways. Let me try to do the things you just mentioned. It's a smaller than and greater than. So I will say operator greater than, let me first do smaller than and equal. And then I will say this one is going to be an integer. And then over here, I would just say return true. I can do this, right? This is operator overloading. And then I can do this. Greater than, I'm just faking it, okay? Just return true all the time. If I do this, I should be able to avoid that particular arrow that I had earlier. Like here, double, I can change this to thing. Okay, now what kind of arrow from double to thing of the first argument? Why is keep asking me double? Oh, I know. I know what's happening. It's not operator overloading is causing the trouble. Is when I call the template, you see that when I call the template is supposed to take a parameter t. And now what is t? T is actually a thing object. And therefore, I have to say, if I actually define a thing object here, t, if I do a thing object here, and then I put the t, and I think this might compile. Let me try to see if this will be okay. Yeah, now this is work. And then it says it's true because I set it up. Okay, so let me show you what I did here. The trouble was because there was the input argument is t. And the thing is that when I create a template, the first argument is thing. That means the argument for the function, the template function, should be thing. But when I call it, I'm actually calling this, previously I was calling like 55.0, which is a double, while this template is expecting a thing. And therefore the compiler see a type mismatch. And therefore it will generate this compiler error this way. Yeah. Yes, certainly. I can do that. Let's try to change this code a little bit. So let's try to do t here, like this, right? All right, so instead, I'm actually going to do this. I'm going to get rid of this. And I'm going to say thing t, something like that, and then return t, such like this. And then over here, I will just say, because I'm calling this one, so I'm going to block this code. Let me try to get rid of this code. I would just say thing t is equal to it doesn't make sense, but I'm going to do it this way. Thing 40, 10, and I better do this. I call this thing t, that's it. And then I call this t2. And then I call it t this way. Okay, so I'm just basically changing it. So it will return the t, and then it will send the value to whatever value that is to t2. And I can compile, and it will work perfectly there. Okay, it doesn't generate any output. Okay, so you can basically, you think about the template, just replacing the label, right? It's purely a compiler concept about how do you replace the label here and there, and then to generate the things you want. Okay, any question about this stage? So I'm going to go ahead to show you how do you do, if you can replace a piece of code for a function, then you certainly can replace a piece of code for class. So I'm going to show you first how do you do the class. All right, so this is the same thing. You take a look at here, I have a template. Look at this piece of code. I defined a template array, a template called class array. It's this block of code I want you to worry about. So this block of code essentially is, you can see that the first line again is what? Is what we call a template introducer, which include the parameter you want to provide. So this is going to be an array of something, array of T. In the sense that this is, in fact, this is very similar to vector. In some sense, it's similar to vector, the way you create the STD vector, but it's a simpler, we call it array. So you define a class array, but you don't know whether this is an array of an integer, array of a double, array of thing. You don't know that. But then you basically say, hey, here's a T, and then the pointer basically say what kind of array it is. So that's the T, that's replaced, and then the size, and then basically you have a constructor, and you have a function called print. So essentially, when you use this template, is whatever T you provide is going to create this piece of code with that particular type. So take a look how we use that piece of code. The way we use this piece of code is here. Take a look at this array. And then remember what I said? If you see a smaller than, greater than, this is the template. So it becomes array of integer. And that's the parameter. And then this is a constructor. The constructor basically has two arguments, that the first argument is some kind of integer array in that case. And then the second argument is the size of the array. So let's take a look at this part. Inside here, you see I define a constructor. The constructor takes two arguments. The first argument is what kind of array it is. I want to initialize this generic array template. And the second argument basically say, well, what should be the size of that array? All right, so if you take a look at this piece of code and matching this piece of code here. Yeah, somebody is spamming me. Sorry about that. And this piece of code here is doing two things. The first thing is declaring a template for the class array, is essentially instantiating top here, and then it go ahead to call the constructor of that. Okay. Any question about this idea of template over here? Well, however, you can see that over here, I only declare the interface for this two function. One is constructor, one is a member function print. But I didn't declare the implementation. Therefore, I have to use another template over here. Another template over here is template T. And then you can see that I have an array T, and then array of this to do that. So essentially, this array T over here is calling the template you just defined over here. Because this is the class T, and therefore this one is going to be whatever array, and then you have the way to implement this two-member function over here. Okay, this is one way for you to do this, but there is another way for you to do this. You can actually do this within the code itself. So let me try to save this, control writer to class template 000.cpp. Okay, so I'm going to do a different way. But before I do that, I want to show you the result of this code. If you compile this class template.cpp, if you run the program, it's going to print you 1, 2, 3, 4, 5. That's the print function. Okay, so now I'm going to modify this. Instead of define one for template class and another one for the function, member function, you can just perfectly do this. You can just copy this part into here. So essentially, I implement this within the first template like this. And I will do the same thing for the second one. Just get rid of a semicolon. Okay, if I do this, it's the same thing. And I don't need this two template. I just need like this. So let's try to compile. Hopefully this will work. If you run the program, it should give you exactly the same result. Okay, so you can split the template or you can put everything together. It's your choice. It's very flexible. The key point about template is just the parameter and to replace within that piece of code. And such that sometimes when you use a template, you have to be somewhat imagining that what the code will look like when you replace the parameter with whatever input argument you're going to put in. And that will help you to understand how to create a template that you really want. Okay. So that's, of course, the other thing I should just mention that in the example I gave you, pretty much everything, I only have one argument, but you could have a multiple, as many of an argument you like, because you might have a lot of different things you would like to parameterize. And as long as the parameter will match the whatever replace, in this case is the T or S, as long as you replace that, then essentially your code will work, okay? Any question? All right, so I'm going to introduce the next concept. So now I'm just introduce you the template. The next concept I'm going to introduce is called lambda. What is a lambda expression? Not this one. I'm going to skip over here. I'm going to skip pointer to function or directly to lambda expression. Okay, lambda expression is kind of nice that you can use it together with a template. Essentially, what's a lambda is a function, but the function doesn't have a name. And also, the lambda expression also is a concept that's only matter in the compiler time. So in the runtime, the lambda is already gone. So let me show you the example about the first lambda. So this piece of code is a lambda. It's essentially doing what we were doing earlier, is in range. But I'm actually using the lambda expression way to represent the same function. So this part is what we call the lambda. I have to go back a little bit. Let me get rid of this. So this part is actually the lambda. So I want you to spend some time to actually parse just this piece of code, this few lines, starting from that pair of brackets. And then you have a bunch of things. I want you to kind of understand. This is probably the first way you saw what is a lambda expression in C++. Okay, so let me ask you, if you see this, let me show you the syntax of this four thing. So that's what I want you to look at earlier. Now I'm going to parse it. Okay, that's the line I kind of highlighted earlier. Let's look at this piece of code. There are in fact 4 different components. The first component is what we call lambda introducer. And then the second one is the argument of that nameless function. And then the third part is the return type. And then it's the body of the function. Okay, so let's take a look at one at a time. So first is a lambda introducer. So lambda introducer is just to declare that the rest of the line is the rest of not really line until you hit that whatever at the end of the curly bracket. That's the whole thing is a lambda expression. So it's called lambda introducer. But lambda introducer in this example, I didn't put anything. It's just a left bracket and the right bracket. But you could put some letter in there to indicate the mode of the lambda expression. But let's not worry about that right now. Let's just assume there's nothing. This is regular lambda expression. So the first part, you can see that I have a, in this case, I have a parenthesis. So in between this parenthesis, this will be the input argument. Okay, let's try to compare the function that we have seen earlier. The range, where's the range function? I want to show you. If you look at this, if you look at this range function, so this is the range function, original one, and you can see that it has a input argument. So by the way, lambda expression is not a template. Lambda expression is just a way to define a function without a name, and you want to use it as an argument later. So over here, you can see that the first one is the input argument. And then this is specifically to the lambda expression. In fact, I should write it this way. It's probably easier for you to understand this 4-line. And the second line essentially saying that, okay, the second line over here is basically say this function is going to return a bool. It just specifies the return type of the function. And I have to move this thing a little bit down, move this a little bit up. And then after this specification about the return type, then you will see a pair of curly bracket and follow a semicolon. And within here is essentially the implementation of that lambda expression function. So if you have this, you essentially specify a function, but this function doesn't have a name. All right, so any question about how to specify? Now let's take a look how this can be used. We actually have it here. Okay, so now you see that this part is what? Is a lambda expression. And I can put that assign into a, here is called atomic variable, meaning that the compiler will automatically figure out what should be the data type of that IIR. Okay, I declare something called IIR, which I put the auto. That means I trust the compiler to figure out what should be the appropriate type. Okay, it's kind of convenient, but later I will show you the exact type for that IIR when we talk about function pointer. Okay, so you can imagine the IIR is just a representation. It's a variable. It's a representation of that lambda expression you provide on the right-hand side of that assignment. Okay, so you assign the whole thing into this. Now the IIR become callable. And now you can say, just say IIR as a function, you can provide a parameter 35.0, and it will return a Boolean variable. Okay, this is called a lambda expression. Any question about this simple, this is the first example of lambda expression. Yes?
For the brackets, does it always have to be that kind of bracket, or does that affect like how it's?
You mean the bracket? The bracket, you if it's a lambda expression, you have to have this pair of bracket. The only thing is that you might be able to provide a different mode, like you can provide a star put inside to actually specify certain property about the function that has, for example, whether the function is allowed to change some variable outside of this function, because the piece of code is basically being generated by the compiler. By the way, everything here is not runtime; it's compiling time. Yeah. Right. Okay, let me show you an example. I'm not sure I have an example over here, but I'm going to. Oh, okay. So let's take a look at this template. This is a template which has a function template and plus the lambda expression. So essentially what I did is I have a template, is also is in range, but then I specify the first one, the type is T, the second one, the type is F. By the way, the compiler doesn't know what it is, but it will just replace whatever you have with that F. And then inside here, it will say is in range T of this, and F is whatever my lambda. And then you can just say return my lambda argument. And then when you call it, you see here, I just call, sorry. Yeah, this is the right way to do it. Is in range 35.0 when I call it, but the second parameter, I just provide this lambda expression over there. It's kind of make the code. By the way, I don't like this style, but it's doable because the code getting harder to read. Okay. And go back to your question. This is a 3 different mode for the lambda introducer. If you don't have anything, it's just empty, it's an independent function. But you can put the equal sign means it's all readable, only reaccess, but you put the n is a rewrite access to those variables within the lambda. Yes. Lambda is best used when you want to pass a function into another function. The function of so for example, I want to define the function, but I want inside the function, it will process the information somewhat differently based on the function I provide. So I actually have a 2 choice to do that. One is put in a function pointer, but the other thing is I just put in a lambda. So essentially lambda is equivalent to a function pointer, which I include the code right there when I call it. So in some sense is not so readable, but in some sense, you have a precise knowledge about what has been passed into this function for that particular call. So I would say the most commonly used, as I said earlier, is just you will be able to pass a different function into another function. Yeah, using lambda. Okay, any other question? Yes, please. Right. Sorry. Okay, in runtime, in fact, everything here about lambda is a compiler time concept. So essentially, compiler will translate the code into some of the real function and putting the function address or function pointer into the code that's generated. So in other words, when you execute the code, it will just call that particular function pointer at that time within that function. So this raises a very interesting point, is that what is the difference of using function pointers such as v-table pointer versus using a lambda expression way of doing this? The difference is that if you use a function pointer, it's at runtime to do the binding between the function pointer and the real function, wherever it is. This could be, there is a concept called dynamic binding. Dynamic binding meaning that you can at runtime to bind another library code, which means that you might be able to execute some code, which is at the time you compile doesn't even exist. That's called dynamic binding. But in lambda is a compiler concept. So you must provide a lambda before you can actually compile the code, before you can actually linking the code together. So therefore, it's really for just a readability about what kind of lambda you want to provide. But pretty much when you go into the runtime, there's nothing you can do about lambda. You cannot, for example, you cannot change the lambda. You cannot use the lambda as a, for example, you cannot save the whole lambda as a string. And then you can try to, at runtime, try to modify the string and try to generate another function. That's not possible with a lambda expression. Okay, so just remember, lambda is a nice way to represent some kind of nameless function for the purpose of parameterization for another function inside another function, but everything has to be resolved at the compiler time. Okay. Any other question? I have 6 minutes. Okay. If I assume you understand this example, so now I'm going to introduce the topic over here. The final topic I'd like to talk about today is pointer or function. Okay, I have been mentioned this idea, pointer to a function, so many times, but I never have a chance to really talk about what they are. So what is a pointer? In C++, when we say the word pointer, it really means address, memory address. So we typically say pointer to object. That means the address of the first byte of the object. So the same thing is if the pointer to a function, that function must already be somewhere stored in your memory. By the way, in C or C++ programmer, everything, the code, the data is already in the memory. And then you have a way to addressing each of this. So essentially what we're saying is that, okay, so if I have an address, I can point to a data such as an object or integer. I can also have an address of a function, which knowing the beginning of the function, then I will be able to use the address to call the function. So for example, we talk about lambda. So what is a lambda? Lambda is a expression which to a function, but the compiler is going to generate to compile that lambda into a function. When you run the program, that function needs to be somewhere in the memory as well. So now you can use the idea of a function pointer to be able to pointing to that function that you generate with lambda or with template or with whatever you want to do. And then you can actually call it using the function pointer, which is that's the way that when we dereference v-table pointer is just basically find out the right function pointer and try to do that. Okay, so essentially you can think about the definition of a function. Function just a segment of code. And by the way, usually is a binary code because pointer to a function, usually we're talking about is a runtime concept. Okay, you have to digest this few things together. Like we talk about lambda, we talk about function template, we talk about function pointer. Sometimes it says compiler, but sometimes I talk about is a runtime. I'm really talking about after the compiler generate the executable code, then the function pointer really makes sense. Okay, that's what I call, what's a function? A segment code, usually is a binary code, object code. And function pointer essentially is the memory address of the entry point of the function. Okay, so let's take a look at example. So here is a syntax for determining a function pointer. If you think about the function pointer is an address of a particular function, but that function must have what we call function signature. So let me ask you, what is a function signature? Function signature has three components. One is the name of the function. The second thing is the how do I say that? The return type of the function. And the third thing is the argument, how many arguments and the argument type. That's what we call function signature. So when we do function pointer, essentially we also need to check whether the function signature except the function name is consistent with the function pointer. So let me tell you that the syntax looks like this. So this line, if you take a look at this line is essentially the declaration of a function pointer. So take a look at this. Let me copy this and make sure you understand this part. That's kind of a bit unnatural, but once you get used to it, you know what's going on. So I'm going to show you this piece of code. How do you parse this piece of code? This, by the way, this is a C. This is not even C++. This is a C code. So how do I actually parse this piece of code? Can you try to understand what this code is doing? I mean, if I do this, you probably know, right? If I do this, bool star FPTR, that should be okay, right? You probably understand this piece of code. It's basically a pointer to a Boolean variable, right? That's okay. But now I have this bool, and then I have a parenthesis star FPTR, and then after that is a double. How do I parse that? Okay, so let me give you some hint for doing this. Number one, if you see some kind of type, and then you see a parenthesis, a pair of parentheses, and within here you have something. I call it something, okay? You have something, but you have a star to that something in between. And then after that, you have another pair of parentheses and then semicolon. And over here, you have something else. By the way, this is not template, okay? I'm just using the sign to represent. Let me actually make it a little bit. Okay, if you have this, if you see this, these two are essentially equivalent. Okay, the first line is a real C code. The second line is my interpretation about what's going on. So bool is the type. That something is called FPTR, and that double is essentially something else. If you see any of this, then essentially what we have, we're saying that this something is a function pointer. Okay, number one, that something is a function pointer. And then we're asking, what is the function signature for that function pointer? Signature, but that signature except the name, by the way, except the name of the function. What is the function signature? So essentially, the return type of the function is going to be type. And then the parameter is actually going to be something else. The argument, whatever argument you have, one or more, is going to be that something else. Okay, over here, then essentially now you can parse the first statement. The first statement basically saying that, hey, FPTR I declare a variable. By the way, FTDR is a variable, it's an address. It's a pointer, so it has to be addressed. In most of the platforms, it's 8 bytes, 64 bits. So FPTR is a variable. What kind of variable it is? It's an address. What about the address? It's an address to a function. And then what's the function's signature is it must be a function that will return a Boolean value. And the input argument has only one input argument, which is a double. Does that make sense? So now you can actually understand. That's the way you specify a function pointer to do that. So let's actually take a look at this. So if I have this, if I declare this one is a variable, right? Oh, sorry. I declare this first line is a variable. It's a FPTR. Look at what I did. I assign is in range to FPTR. I assign that function to FPTR. So FPTR becomes that function. That's actually to the double. And then how do I call it? I dereference. So it's interesting when I dereference a variable, the pointer is go back to that data variable. But when I dereference a function pointer, that means I'm actually calling it. So this way is I do a star FPTR to 0. Okay, given that I have a function called is in range over here. Okay. I probably used that a lot of time, but there are a few examples in the CPP 15. They're essentially using 3 concepts together. Lambda, function template, and function pointer together. By the way, you can assign a lambda. I have an example here, in fact. Sorry, just give me 1 second for the lambda part. Over here. You see that? What I did? Okay, this part is just putting this template into the function pointer. But I have another, okay, here you can see that I can also use function pointer to put in the lambda. I declare the function pointer using this line, the same line I showed you earlier, and then I define a lambda, and I assign that lambda to the function pointer, and I can call the function. So essentially, you can use either template to assign to a function pointer doing this, or you can use a lambda to do that as well. That's basically give you another tool to manage your function in your program. Okay, I'm going to stop here. Any question? Okay, I just want to tell you, if you want to pick up your exam, just follow me. I'm going back to academic search.